So, we're here to talk about chapters 2 and 3, and then I want to demonstrate these projects, which I was unable to last time because my remote machine was not working, and I think it's working better now. We're going to see. So, let me start with the slides, which I've got here. This is 126. All right. And I can see the Twitch now, so I can tell the questions easier. So we'll be a little bit better off here than we were last time. Now I have two screens anyway. Okay, so there's the Twitch. All right, there we are. So we already talked about this a bit last time, but if the most easy and fun way to analyze malware is to run it and see what it does. And that's what we do a lot, and therefore you have to have a machine you can throw away, a safe environment. You could use a real machine that is not connected to any network. That's air gapping. That's what the military does. And that would work, but it's very inconvenient. The problem is you have no internet connection, so the internet that tries to phone out to servers won't reach it, and therefore it might not show all the interesting function. And of course, you keep having to re-image that machine after you infect it, and that's kind of a lot of work. So the one advantage, though, is malware will typically be fooled by that. If you run it in a virtual machine, some malware will realize it's in a virtual machine and not do its malicious stuff. Putting it on a real machine will probably avoid that, although some malware, especially that from nation states, like the stuff the NSA writes, is actually very carefully targeted, like Stuxnet. So it will check to make sure you are really the targeted machine, like you're in Russia or North Korea or something. And so you might discover that even running it in real hardware is not enough to fool the malware into doing what it's supposed to do. Yeah?
Do they do that by running a particular assembly instruction that's particular for that microcontroller?
There are many techniques, but one simple technique used by a lot of malware is to just ask what the language of the machine is. There's a Windows API call to find out what language the machine is set to. For example, most Russian malware will do that, and if the machine is set to Russian, it will not attack it, because the rule has been in Russia, I don't think it's an official law, but it's been Putin's rule for a decade or more, that it's perfectly fine if you attack other countries with Russia, and he will protect you, but if you attack Russian citizens from Russia, then he'll prosecute you. So most Russian people write malware that will carefully not attack people in Russian-speaking machines. It's the easiest way to do that. And China and North Korea have done the same thing where they look at language. You could try to look for geolocation, and of course for Stuxnet, it looked for exactly the specific hardware they wanted. They got the hardware from Siemens. They knew like the serial number of the exact devices to attack, and so they would check, and it wouldn't do anything bad unless they were exactly at the right target.
And that was in the designation of the machine was a comment in the source code that can be queried by.
Oh, well, it won't be a comment, but it's probably a string. Yeah, it's probably not too well hidden. It could, in principle, be hidden, but normally it's right there. It looks to see if some value is the expected value. Very good questions. And we'll see some examples of this stuff later. Machines that are malware that is picky. And so what's easier, anyway, so that's one advantage, using real hardware. And I say that's what you really have to do for Android malware. But for Windows, it's usually fine to use virtual machines, and it'll be fine for everything we're doing here. There are some attacks that escape the virtual machine and infect the host, just like there are some attacks that will escape Docker containers and infect the host. I should mention Docker containers. They're too recent to be in your book. Docker containers are like smaller, faster, cheaper virtual machines. And they do this by using something called the overlay file system. Now, a virtual machine, I was horrified when I first started using virtual machines. In 2004, Microsoft came out with Virtual PC. And so you have a whole hard drive, you have a whole installation of Windows, several gigabytes, then you make a virtual machine, it simulates a new hard drive and another copy of every file. And I said, this is horribly inefficient. It makes a second copy of all those Windows files, but that's what virtual machines do, and they're therefore considered quite secure. You're really isolated. If your malware writes any file to the hard disk, it's only going on the virtual hard disk, not on the real hard disk. But the overlay file system is very different. The overlay file system creates a virtual file system where every file used by the Docker container is exactly the file used by the host. And if you change something in the Docker container, it only stores the changes. So if you put a Linux container on a Linux host, almost all the files are identical. And only if you install some software in the container, it'll change a few files. That's why it's much faster, much smaller, much cheaper. If you have a server that could run 10 VMs, it could probably run 100 containers. So it's incredibly popular, but they're famously less safe. People have been warning many times that the containers are not as isolated from the host as virtual machines, and there are container escape things that attack the host. So people use them like crazy, but it's, anyway, for malware analysis, I think it'd be wiser to use a real virtual machine.
You have to change the file in the house.
Yes, depending on how you start the container. In fact, many versions of containers actually run as root all the time, and some of them can directly change the host. So it's pretty easy to escape from a container onto the host, although as Docker improves, they make it harder. It's a very young product. So anyway, that's an important thing to know about. Yeah?
If you're gonna run a VM, what would you recommend? Like either a Linux container or like a Windows container for efficiency and like so you can get as much information.
Well,
and what program would you run to get the log?
To get the lock?
Well, to get the log, like what it's actually done.
Oh yeah. Well, we're going to do that later. You run
Okay.
programs to monitor, but the in this case, you need a Windows machine. You need a Windows virtual machine in this class because
Okay.
we're doing Windows malware.
Okay.
So if you make a Linux machine, you won't report for anything you're doing here. We use it in other classes though. So here you need a Windows virtual machine.
Okay.
Any version
Yeah,
of Windows
sorry.
will do that.
I didn't realize that was part of the.
Yeah. No, but this class is only doing Windows malware.
Okay.
Good. All right. Anyway, this is good. In my other classes, though, we use Linux machines quite a lot. And by the way, you can also use cloud machines, which is another pretty good idea. If you put your analysis machine on Azure or Google Cloud, then it's not anywhere on your network, and that's even safer, of course. Then if it was to escape, that would be their problem. And so you're probably violating some terms of service, though, I'd imagine, deliberately putting malware on an Azure cloud machine. But, you know, I'm sure it happens all the time anyway, that they get infected, so I'm sure they have defenses. I would think if your malware escaped an Azure cloud machine, they would not blame you and punish you. They would just try and improve their security. But I haven't done it. Anyway, so, all right. So VMware Workstation Player and Fusion are the best products to use, in my opinion. They're the most mature. They're the easiest to use. There's a bunch of other ones. VMware Workstation Player is the free Windows product. Fusion is the product that runs on the Mac. It used to be you'd only get a 30-day trial. Then they made it free. Now it seems to be awfully hard to get registered for the free one. So I'm not sure. You might only be 30 days free now. But anyway, there's a lot of other products out there. VirtualBox, Microsoft's Hyper-V, Parallels, Zen, Qemu for that matter. There's a bunch of ways to run virtual machines. And in principle, they're all okay. But VMware is usually easiest to use. So in VMware, you can make a virtual machine, and you could make it so it connects right to the internet, just like your host. And that's usually what you actually do if you're an American. But remember, I went to a malware analysis workshop from an international group, and the Germans were there, and they said, you would never do that. Why, the malware will connect to your command and control server, and your location will be flagged as hosting malware. And we would never do that. They say, we do this. We make a fake simulated network so it doesn't connect to the real internet. And the Americans all said, yeah, that's too much bother. Who cares? There could be one more bot for a while. One more infected machine. We just do whatever's fast and efficient. That's what I do. Sloppy and efficient. But anyway, so you could do this. You could make your virtual machine only do host-only networking, so it does not get to the internet. All it can do is get to the physical machine, and then the physical machine goes to the internet. That's another way to do it. There's a lot of ways to configure the networking, but most of the time, if for our project, we're just going to let our virtual machine connect right to the internet because we don't have to care about being super sanitary and clean with the simple malware samples we're analyzing here. So,
NIC stands for what?
What's that?
NIC stands for what?
NIT?
NIC.
Nick, Network Interface Card. Good, thank you. Good? Yeah. And so here, what we're mostly going to do is NAT mode, Network Address Translation mode, because that way your virtual machine goes through a virtual router, so it goes to the internet, but it's on a separate network than the host machine and other machines in the room. So it's less likely to spread over the network. You could do bridge networking, and if you do that, then your virtual machine connects directly to the network your host machine is on, as if there was just a second computer in the room, and then it could access file shares on other machines in the room and possibly spread, so that's not as good. That's normally use NAT mode, which is the default in VMware, one of the many reasons I like it. Anyway, like I say, this does mean that when you infect it, your machine is now going to do some hostile things perhaps. It might participate in a DDoS attack or something. So that's why your purists would not let your infected machine connect to the internet at all, but people that just want to get the job done, accept contributing a little bit to the botnet for a while. So you can also use snapshots if you get, I don't know if the cheap free versions of VMware have this, but the pay ones do, where you can take a snapshot of your machine, and then you can launch the malware, analyze the malware, and when you're done, you can just revert back to the snapshot. You don't have to restores your machine back to a clean condition easily. All right. All right, so there's risks, of course. In principle, you might not get the right answers in a VM because your malware might be VM aware and not do the same thing in there. VM, of course, has bugs. It is not a perfect simulation of a real machine, so it might cause the malware to crash or something. And in principle, it might spread or infect the host. The samples we're going to use are harmless. I want to be careful about this. They do not spread and infect other machines, and they don't wreck a machine so it won't work, but they do self-launch and are a little bit hard to remove, so you don't want to just put them on your favorite machine. But they're not harmful spreading malware, but they do demonstrate the techniques of malware, so you want to put them in a virtual.
Antivirus software after this class, will it find all of that stuff?
Oh, I think it will, yeah. And that's right. But that's why you need to have a virtual machine without any antivirus on it to run these samples, of course. Yeah, because they've all been reported. I think some of them I rewrote. They might not be caught yet, but they'll probably be caught pretty soon. Yeah, and they don't do anything very nasty. But they do demonstrate the techniques of malware, which is the point. But none of them spread. That's the main thing. You're not going to be infecting other people, which would get us all in a world of trouble. All right. So dynamic analysis, like I say, now first you do static analysis, simple stuff, like looking at strings and looking at the file headers to see what libraries it uses. That's the first thing you do. That's the easy thing to do. But often you don't learn enough that way. For example, you can write code that obfuscates the strings. They're all scrambled, so you can't read them. You can use a packer that compresses the code and then has an unpacker, and then you can't see anything about the compressed code. All you see is the unpacker, which is not interesting. So, you can hide the interesting details of your malware, so a static analysis technique will not work. And therefore, dynamic analysis is your next step. And after basic static, you actually go to basic dynamic. Now, the easiest way to do it, of course, is just automatically. There are sandboxes, there's a bunch of them out there, like Joe's Sandbox and a bunch of others, some free and some pay, that are just designed for this. So you upload a file, it automatically launches it in the sandbox, it automatically monitors a bunch of things, and then it just gives you a report. It made these network connections, it made these files, it made these registry keys. VirusTotal does that now. We'll try it later. It's very nice. So these are easy to use, and in a sense, they automate what we're going to do in this class manually. All right. And so then you run your malware. Now you can just run EXEs, of course, by double-clicking them. But if you want to run a library, you can't. You need to have an EXE to launch it. Now normally, you only have libraries, you only run them to the EXE they're connected to. But if for some reason you want to run a DIL alone, you can use the Microsoft utility, runDIL32. You can use that to launch it. That will launch a library. And we'll learn a lot about how libraries are structured and how they work as we go ahead here. All right. But you can run any function in the library that's exported. Each library exports functions so you can connect to it. And you can run it with arguments too. You can with runDIL32. So rip.dil, which I think is routing interchange protocol, a really old routing process, you can install it by running rip.dil, install. That'll execute the install function in the library, and it doesn't have any parameters. So that's what you might do. Sometimes they use ordinals instead of names for the functions and so on. But we'll see this as we go ahead when we look at some libraries in future class. We're doing quite a lot of with them here. And you'll be writing libraries, and you'll be writing malicious libraries. So maybe that's the exploit development class, but we'll see. Anyway, we'll certainly go into libraries a lot here. So Process Monitor is one of the tools you use to monitor your system to see what the malware is doing. This is probably the most useful tool. It is really nice. And what it is, by the way, is just a graphical view of Windows Event Viewer. Microsoft event logs contain all kinds of information in a very unwieldy and unhelpful format. Just opening a folder is like 100 events. It's nuts. So this boils it down to simple, understandable events like a file created, a network connection created, things like that, and you can filter them easily. So it's very nice, and we'll play with it soon. So you run this thing, and it shows you things like here's explorer.exe, opening a registry key, closing a file. Here's running calc, opening a key, creating a file. Nice. You can see just what it does here. Let's see, questions here. My audio is breaking up. Oh, I hope it got better. Let me know if you can't hear me, folks. I'm not sure I can do anything about it. Would I expect most enterprise servers to be VMs? Yes, absolutely. Every server you connect to on the internet is a virtual machine now, or a container. Almost nobody runs anything on bare hardware anymore, just because it's cheaper to run in containers. Here, let me turn on the local lights here. It's going to get dark. There we are. Anyway, yeah, I don't know. Hardly anybody puts anything on bare metal anymore because it's not efficient. There's a lot of reasons for that. One big reason is before there were virtual machines commonly and everybody ran on bare metal, they checked and most CPUs were running at 20% of their capacity. And they said, we're wasting 80% of our money. We're not really using it. Whereas if you put in machines, you can pump that up. Another bigger issue is if you have a cluster of machines all working together on something, there was a company that gave a presentation at a VMware conference I went to, and he said we had like 100 servers. And so we had 100 servers working together, but then what happened is time passed. A couple of years later, a bunch of them broke, and the components went obsolete. And we had to have a whole room full of like broken machines we'd harvest these old components out of because the cluster won't work unless they're all exactly the same. And it gets harder and harder to get this old stuff, and it's more and more of a shame to keep maintaining old machines that are out of date, and so we made them virtual. Now we have new hardware and old hardware, but they both run identical virtual hardware. Now we have a cluster that works, and we can just replace the slow old machines with brand new machines that are fast and integrate them in, and it saves you time and money. So that's why almost everything you connect to is a virtual machine, for that reason. Anyway, so this is what happened just from launching Calculator. A bunch of events, but it's better than what you see in Event Viewer. So in the toolbar, you can start and stop capture with magnifying glass, which I find very confusing. I normally think that would be a search button. You can erase things, you can filter things, which we're going to do quite a bit of, and you can choose general filters here like just the registry, just the file system, just the network, or just the processes. But the main thing we're going to do is enter manual filters to filter for the type of thing we want. For example, for simple malware like the stuff we're going to use, you can just filter for the name of the malware. Only show me events executed by a process with that name. Now, smart malware might be able to hide from that, but dumb malware, that's an easy way to see just the good stuff and not all the background activities that don't matter. All right, and so one technique that is recommended, I think, in your book, which I've tried, which is harder, is first you run your machine, then you go into a process monitor and remove everything until you see nothing. Then you run the malware. That's the way you really make sure you're going to see everything the malware does, even if you don't know what names of the processes it might spawn. That seems harder than it needs to be with these samples, so we're going to do it the other way. But anyway, that's a good plan. Include is easier. Now you just have like process name is calc.exe. You can have rules with process name, operation, detail, and many other filters. You only see things that obey these rules. All right, and then there's now that is process monitor, which gives you a time track of all the things the malware has done. Process Explorer gives you an immediate view of what's running right now. It's the souped up version of Task Manager. So you'll see all the processes on your machine. And for example, the system idle process is at the top. That's just the CPU time that is not being used. Then the system boots up. It's more or less in time too. Here's all these system processes going. And then you have Windows, and at some place you'll have login. Anyway, that's what it looks like. And we'll look at it live and go into more detail of it later.
Sam,
Yeah.
for the process monitor, it's only show you the events in the time history.
Yes. It just shows you a time history of things. That's right. And by the way, one thing fun about it, which you might be able to see here, yes, notice this is showing 128,000 of the 253,000 events. That's the thing. If you leave this run for a while, it'll just fill up the RAM and crash, just like Wireshark would. It's got too much data. So you only run it for a few minutes while you're analyzing the malware, and then you stop it, and then you examine what is caught.
Why do you need to use an exclude in the process monitor?
You don't. Well, in Process Monitor, you have to use either include or exclude just to remove the uninteresting stuff. As you can see, there's far too many events. So you have to somehow filter it down to the ones you like. So you would use exclude is the cleanest technique. You exclude all the processes that are in there before the malware.
But you think time slot in the period of time, right?
Yeah, you also have time. You could try that, but of course the operating system is doing a lot of things in the background all the time, and you have to exclude all that. You only want things done by the malware. Yeah, good. All right, good questions. All right, so in Process Explorer, Services are pink, processes are blue, new processes are green, processes that terminate flash red, and we'll play with that a little later. Anyway, so you can also view the DILs. There's a lower pane, so if you do that, you can pick a process here like Chrome, and down here you'll see all the libraries it's using. So you can get a lot of information about a process. You can even tick a process and go to Properties, and you can see a lot more about a running process, many tabs of information. For example, here, you can see whether it's using data execution prevention and address space layout randomization, which we're going to talk about a lot. Data execution prevention is turning off the execute bit in RAM. This is a feature to stop buffer overflow attacks, which we do a lot in the exploit development class. In a buffer overflow attack, the classic kind, you have a field for something like a password. You type in a password that contains assembly code. Then you enter it as data, and then you execute it as code. You trick the program into misunderstanding data as code. And to prevent that, they introduced this data execution prevention. They make a memory region where you're going to put in data called the stack, and they marked it read, write, but not execute. The rules nothing can be write and execute at the same time on a Windows machine is the security policy. It's not enforced though. But anyway, data execution prevention does enforce that. So if you do inject code into data and then try to run it, it won't run. It doesn't have execute permission. So that was really powerful at stopping a whole generation of malware that infected Windows XP and earlier. And another one that also helped was address space layout randomization, which came out with Windows Vista and all modern versions of Windows. And what this does is it used to be, if you had, say, 1 gigabyte of RAM, your first program would just start at the bottom, next one would start on top, next one would start on top of that, just in order. So you could predict what RAM is being used by a program. But they fixed that. Now every time you launch a program, it randomly picks a RAM location and all the available RAM and moves it to a different location every time. And the point is, now even if you're able to inject code somewhere and you're able to execute it, you can't find it. You don't know where anything is. So these two defenses prevented a whole generation of malware, pretty much all the malware up through Windows XP, from running, and made Windows Vista a lot cleaner for a while until the exploit development community updated their game to get past these. So anyway, now there's a button you can do to check the Windows signature if you have signed. Yeah.
Would that help? The last thing is, would that help if their attackers are already in RAM and they would that way they can't predict what's going to be used?
Well, yeah. The point is, typically the attack here is you have a running process that accepts input from the user, like a login, and you feed in data, and all you can do is put in that data. And you don't know, and then, if you have a buffer overflow, you put a name in a field that only has room for, say, 10 characters. You can put in 1,000 if they don't catch that. Then you're writing to memory that was not reserved for that purpose. And you're able to hit control structures that let you control the instruction pointer.
Right.
So you can now jump to a location. There's two problems. The only location you can jump to that would help you is the location of the stuff you injected, which is in the data section of memory. Which is probably not executable because of data execution prevention. And the other problem is you can put in an address, but it won't do you any good unless you know where that data is going. And you won't know because of address space layout randomization.
Right.
So,
well, I was referring to like if they're already in there doing something.
Well, yeah, if you're already able to execute arbitrary code on the machine, then you've already lost. And then, of course, they can just allocate memory and give it the permissions they want and get it wherever they want and go to it. Yeah, I mean, this is all to stop you from getting the ability to execute code in the first place. Once you have that, of course, then it's over. Good. Anyway, so you can compare strings. This is actually very nice. You can view the strings of a running process. The way we did before, we talked about it last time, we'll do it today with bin text. These are strings of a running process, so you'll see the messages in the machine. So you've got here, just see, any of this is interesting, just looks like normal messages here. None of these are terribly clear. Here's just the name of a DIL library. Sort of thought I might see some Windows API calls, but not right there in that screen. Anyway, the point is, you can do the image, you can do image or the memory. The image is on the hard drive, the memory is in RAM. Now, when you launch a normal exe, it just copies segments from the exe into RAM. So what's in RAM is just identical to what's in the exe, although it's spread out a little with gaps. But if you find that the strings in memory are different than the strings in image, that indicates a process replacement attack, which is very cool. If you want to run a malicious process and there's already another process running, you can put it in a suspended state, change the contents, and then resume it. And now it's running a different thing in memory, but it still thinks it's running that old process name. It'll pass the tests. It'll go have the permissions of that process. It's very cool. It's like a zombie. You take over a process and make it do something else. But you can detect that here by seeing that the strings in RAM do not match the strings on the disk. And
You manually find the difference, right?
what's that?
You have to manually find the difference, right?
Yes, this doesn't do the difference for you. There are tools that do. I think there are some Mandiant tools I think that do, but we aren't using them yet in this course.
It's very hard for a user to find it.
That's true, but it can be obvious, yeah. It's just a clue you might find here. Anyway, now, so if you open a malicious document with a vulnerable application, you could then watch Process Explorer to see if it launches a process. For example, this is a very common issue for PDFs, for example. PDFs in vulnerable versions of Adobe have the ability to launch other processes. So do Java apps. And you could see if it does that. You could open it and then see if it launches another process by watching in Process Explorer. And then you'd see where it is. All right, and then of course you can do registry comparisons. Now, I don't like doing it this way, by the way. I find it more handy to detect registry changes here. It'll just put the registry changes right here in Process Monitor, which is nice. However, there's another way to do it, and it's good to have multiple tools because, remember from before, a lot of your tools fail. So here's a simple one. This is Red Shot. It just makes a copy of the whole registry. You make a first shot and you make a second shot. Then you compare them. You could easily do this yourself with Python or anything, but that's all it does. So you take a registry shot before you run the malware, you take another registry shot, and it can easily compare them and show you the difference. You'll see what keys have been updated. So that's a useful tip to get the registry. All right, and then like I mentioned, there are tools to fake a network, which if you want to be sanitary and not let your malware phone home, you can make a simulated internet. INetSim is one of the several programs that does this. This one will run on Linux. And it simulates the internet. It listens on a whole bunch of ports. You can configure it, but by default it listens on all the common protocols. The problem is it just gives generic answers to them. Like you can go to any web page and it'll let you see it, but it's always the same page. It's a pretty thin imitation of the internet. But you can do it. If you want to, just listen on one port. You can just use a Netcat listener, NC on Linux or NCAT on Windows. And this will just let you listen on one port so the malware can at least connect to you, but it won't find whatever it was expecting there. So it won't fool it very much, but at least you'll get the first few packets of the network connection. So here, for example, I'm just listening on port 80. Then I open a web browser and go to that location, and I can see the request come in here. But down here, I just get a message, this web page is not available because we're not running a real web server that serves up anything. I'm just running a responder that completes the handshake. So that's the kind of thing you'd get with it. Now, INetSim would do a little better. INetSim would display a web page, which is configurable, but by default just says like sample web page or something. But anyway, you can do that. Like I say, it's usually not worth the bother. It's a whole lot easier to just connect to the real internet, let the malware connect to the real servers. All right. You can also use Wireshark, and we'll use this. Wireshark is the main tool to look at raw packets. This is how you see what your network card is doing. You just see every line as a packet being sent in or out of your network card, and you can record them and save them and analyze them in great detail. So we'll do quite a bit of that. Now, one way to use Wireshark is to look at packets one by one here with summary, where you have source and destination address in the summary. Then in here you've got a hierarchical display of it, and down here you got the binary display. So this is good if you really want to go deep into one packet, but normally you don't. Normally you want to follow a conversation and see what happened. And for that you can use follow TCP stream. That removes all the addresses, and you see, here's the request, get CGI, going in, here's the response. You can see the request and the response, minus all the timing and address information. So we'll do that when we get to the projects. And so INetSim looks like this. You run INetSim. You have to configure your Windows machine to use the INetSim machine as its DNS server, because it's going to have to look up domain names, and the answer is always going to have to be here. It's not going to simulate multiple IP addresses. This machine has an IP address, and you tell it to use it has a DNS server, and it will then show you this page. Everywhere you go, fred.com, every possible website will just have this same web page, because you're really just looking at one machine. So, all right, it fools Nmap, though. If you run Nmap, doing a scan on .NET Sim, it'll find all kinds of open ports. Every common service is available, FTP and internet and everything, of course. All right, anyway, so in practice, Procmon, the simplest thing is just filter on the malware executable name and clear all old events. Then you're going to see only the stuff run by the malware directly. Then Process Explorer, Redshot, a virtual network, and Wireshark, that's one way to do it. This sort of things you run. I was pretty horrified. I mentioned last time when I first discovered you actually run analysis tools on your test machine, which you're infecting, and then you think those answers mean something. I was offended just like the Germans are offended of it. I said, that's sloppy. And they said, yeah, it's sloppy. We're doing the sloppy, fast test because it usually works. But be aware that it might not work. Obviously, the malware is infecting that machine. It might foul up the tools. So that's, like I say, it's important to know you can't trust any of your tools too far, because you do have intelligent adversaries, and they know all these tools, and they're writing things. Let me tell you, this is a good one. Years ago, maybe 15 years ago, I had a student come to me, and he said, I'm the network administrator at my company, and please, I'm not an idiot. And the guy that told me this is not an idiot, and he told me he got infected, and it turned his Windows XP into Windows 98. He said, and I said, I remember a time when I would have said, he's just making it up. But I'm not going to say that anymore, because I've been in this game for a while. I looked it up, and it's real. This was malware, and what it did was it would anticipate all the things you would do to clean it off. So if you tried to go to online antivirus sites, it would stop them. And if you tried to run system updates to get rid of it, to improve your machine, it would play a video of the Windows 98 Windows update going through. So you would see these Windows 98 screens going by. So this kind of stuff happens. Anyway, so that's the thing. Your enemies are evil. They know your tools. You will get stuff that doesn't look right. Yeah.
Well, real naive question.
Yeah.
We're learning as humans how to interact either statically or dynamically to detect this.
Right.
Why is there not a process that is a meta process running on one of these cores that when you're coming on with a cold, you kind of know it's coming on? Why isn't there a process, a meta process running?
Yeah. That's what the endpoint protection suites attempt to do. The modern antivirus and endpoint response suites, they do try to monitor everything and detect suspicious activity and block it. The problem is, the only thing that really works is signature detection, where they have a list of known malware and unique bytes. That works. That's what antivirus does. The behavioral heuristics have too many false positives. The problem is there's all these developers writing stuff and using all sorts of weird techniques, often learned from criminals, often imitating criminal activities. So a bunch of innocent things like an installer that unzipped will trigger your heuristic thing and be flagged as malware. Now, one thing that really works, by the way, is available in Windows, and it's the default in, I think, one of the Finnish antivirus product, with Mikko Hyponen, I forget the name of it, F-Secure. That is whitelisting. What you can do is you can just have a list of known good commercial software and not let anything else run. Unless it's a known product, it won't run. And that's essentially what an iPhone is. iPhones only let you run stuff that comes from the App Store, nothing else. And therefore, there's essentially no malware. You don't need any antivirus. You don't need any firewall. But you also can't run anything weird. You can only run stuff that Apple likes. And you can run your Windows machines in modes like that. There are ways to do it. But most people are not content with that. Most people want to write their own scripts. They want to write their own code. They want to download games and stuff and free utilities from dodgy sites and run them. And of course, the problem is nothing can really tell that stuff from malware. You got a bunch of amateur written stuff, sloppy using goofy techniques. That's the problem. So it's a very good question. This is why, if you want a safe computing environment, you give your people iPhones and iPads, and then you use a virtual machine on the cloud, or you can really lock down a Windows machine to where you can't do much. I've got some of that in my corporate consulting. I had a machine, I can't install anything. If I want to install anything, I have to go to the official corporate store and submit a request, and they will only let me have it if it's known good. And stuff like I can't even get administrator rights to install a device driver without explaining on a form I need it and waiting for a while. And then, they're not messing around. They don't want you infecting that machine. And then it's, of course, irritating. But it's much safer. Anyway, these are good questions. All right. So anyway, here's what you'll have. In this case, you have a virtual machine. It is doing DNS and being told to go to the same machine for every service and every process. So this one machine is the whole internet as far as this machine is concerned. That's what's going on with the simulated internet. All right, let's try a Kahoot. This is chapter 3, and I should have them here. There we go. Yes, all right. Good. And this is going to be 126, chapter 3. There we are. Okay. Ooh boy. I think that's Abdul getting happy with the favicons, or whatever those things are, emojis. Those are pretty wild ones. Squids and shrimp and crabs, okay. All right, I'll give it a few more seconds. Oh yeah, people still coming in. All right. Looks like I got everybody. Ah, that V is a special character too. These folks know they're learning some Unicode. All right. All right, so what method makes your malware smaller? All right, packing, just like a zip file, it gets smaller. All right. All right, what kind of file do you have to execute using Rundle 32? Yeah, that's a pretty easy one, like who's buried in Grant's tomb. Anyway, so that's still files. All right, so. All right, which one records thousands of events per second? So you have to ignore most of them. Oh. Well, it's extra credit, which is part of that, yeah. But this process monitor, not to be confused with process explorer. Process monitor is the one recording all the events. All right. All right, and which tool shows your Ethernet frames? That's Wireshark, good. All right, and which tool lets you analyze malware without contacting a real server? That's INET Sim, of course. All right, let's see who won. All right, looks like a real name. That also looks like a real name. Good. I know who that is. All right, good. All right, I'm going to stop the recording. There.